Okay, so welcome back. This is part two of solving the leg of using Pythagorean Theorem. Of course, remember we can only solve the distance of one of the legs or the hypotenuse of a right triangle. So here we're going to check our answer to make sure we got the value of A correct. And this is how you can do it for any exam. Remember, if I'm going too fast, please stop, pause, rewind the video, watch it as many times as you need to, and then pick up where you have left off. All right, so the first step, and remember in the last video we solved for A. A was the value of 2 times the square root of 11. B was given and C values were given. So step one in checking your answer is to substitute the value into the formula. So square root 2 times the square root of 11 to the power of a 2 plus 10 to the power of 2. 10 is my value of B. And then my value of C was 12. So what we're going to do to solve is we're going to simplify following PEMDAS order of operations. Not much to do inside the parentheses. So now we're going to square root both of these sides. So step two, hey, follow PEMDAS. Please excuse my dear Aunt Sally. Parentheses are first, exponents, then multiplying, dividing, and then adding and subtracting. So real quick, let's go back up and see what we see here. When we substituted the formula, 2 times the square root of 11 to the power of 2 means this term times itself twice. Just like 10 squared is 10 times 10, 12 squared is 12 times 12. That's what you're seeing here in step number 2. Okay, and let's go ahead and simplify these values as you see them here. So I'm going to go over this step by step. So 2 times the square root of 11 times 2 times the square root of 11 plus 10 times 10 equals 12 times 12. So here you can multiply 2 times 2 is 4. And you treat these radicals as if they are a variable. They must be like terms if you're going to add or subtract. Of course, when you multiply, you can multiply what's inside these radicals. So 11 times 11 is what I show here. Now there's two ways to simplify this. You can multiply 11 times 11 to get 121 inside the radical, and then multiply 4 times the square root of 121. Or you can see there's a perfect pair of 11s. You can pull one 11 out, and that would be 4 times 11, which would give you the value of step 3. I'll show you in a moment. So again, when you have a value that's squared, it's the term times itself. So 10 times 10 is 100. 12 times 12 is 144. Again, 2 times 2 is 4. And I'm just going to show 11 times 11 inside the radical. The next step, I multiply it. So you could just take the perfect pair out and multiply it times the 4, like I instructed on the last video. Or you can multiply 11 times 11 and simplify the radical further, which is what I'll do in step number 3. Let's go ahead and take a look here. Step number 3. So in step 3, I want to simplify the radical. Okay, I want to show you how I got to 44. And again, you could got a perfect pair of 11s, pull that 11 out. 4 times 11 is 44. That's one method you could use. Or I'm going to show you using my calculator how you can multiply 4 times the square root of 121. Okay, and then we just brought down the plus sign, we brought down the 100, brought down the equal sign, and brought down the 144. Let me show this to you now. So I'm going to multiply 4 times the square root of 121. Clear, clear, clear. 4, I hit the 4, I hit the multiplication symbol. In order to take the square root on my calculator, I got to punch that in first, so 121. Then I'm going to hit the shift button, then that golden square root, and that gives me, don't forget, you got to hit that equal sign, and that gives me a value of 44. So 4 times square root of 121 is 44, which is what you see right here. Okay, again, another method, you got a perfect pair, pull that 11 out, multiply 11 times 4, and that's the other way you could have simplified to get 44. All right, so now we're here at this third step. We've simplified the radical. Now we want to add these two values, simplify a little further. So 44 plus 100 equals 144. So the final step, hey, you're going to add these two. We just talked about that. Does 144 equal 144? Is that a true statement? Yes, it's absolutely true. The left side equals the right side. So, by that nature, A has got to be 2 times the square root of 11. This is how you're going to check your answers on any Pythagorean Theorem type of problem. I hope this was helpful. Again, this is a recorded video, so go back, watch it as many times as you have to, and hopefully this will help you out. Thanks for joining. Take good care.